So, welcome back to the lecture number 7, and today we will be talking about classes, objects, structure, and then at the end we will talk about multi-dimensional arrays. We have see the single dimensional arrays last, I think lecture number 5, and today we will also see that we have multi-dimensional arrays, just like we have 2-dimensional things, 3-dimensional, 4-dimension. So, we can look at that, how we can handle if we required to have the data or save the data into the multiple dimensions. So, first thing is classes, a structure that encapsulate a set of data and behaviors. So, if we look at our program, what we have? We have two things inside it. Number one, we have some data, maybe the name of the student, first name, last name. You can say that we have the student ID, we have address. So, all these are informations. We talk about the marks, average marks. This is the data that happen to be in our program, and we need to manipulate, we need to manage it, we need to process it. So, that is a one part of our program, data. And what is the other part? The other part is we do some processing on that data. We have scores of 50 students in a class. We need to find out the maximum, we need to find out the minimum, we need to find out the average. So, what we are doing? We are doing some processing on that data, and that is the behaviors, or we call them methods. So, we pass a list of marks to a method which return us the average. So, it is doing some processing, it is changing that data, it is managing that data and returning us some answers. So, in every program that we talk about, we always have two things. One is the data, informations that we need to process, we need to manage, maybe save them, maybe whatever. I mean, we can say that whole data process management. And then we have the behaviors, what we are going to do with that particular specific. We are going to save that into the file, we are retrieving that data from the file, we are saving that data into the arrays, processing them, finding the maximum, finding the average, putting them into the cloud. All these are the processes that we need to perform on the data, and these are called the behaviors. When you say class, class is actually just a blueprint of your design. For example, we have, I show you this particular specific picture here. In the picture, I can see that there is a layout of the house. On the top, it will show me, it is not the real object or the house, but it just show me how it will look like. So, does this paper, or maybe that's an electronic file, does this constitute to that can replace the actual house? It's a design that will give me the details, how I am going to build, what will be the size of the rooms, where that particular door will be, where my kitchen will be, all that kind of informations that are necessary for the builder to build that house. But it is not the house itself. So, when we talk about the class, class is actually a blueprint of the house. That is not the actual object, that is not the actual thing. Okay? So, we need to understand that particular specific concept. Class is a blueprint which can tell us what will be the information about this object we will have, what different type of processing we can do in that particular specific object, but it is not the actual object itself. Okay? And once we will see the example, it will be much more clear. And then the third thing is a reference type, value type objects. So, value type values, value type variables and the reference type variables, int, float, double, character, primitive types, they are the value type, and the string, We have the arrays, we have studied the arrays. These are the reference type variables. So class is also a reference type variable. So whenever we are passing actually class, or we say that instance of the class, then we are actually passing the reference of that instance or the object to the method, to maybe passing from one point to the other, but we are passing the reference, not the value itself. So class can contain, it can contain fields, int, number, string my name, string address, or maybe another class. Okay, it's not necessary. That field can be a variable that you can define, it can be a field here. It can be a value type, simple primitive type variables, double, float, int, character, boolean, whatever it is, or maybe a reference type variable like a array, or maybe another class object here. Anything that you can define as a variable, it can come into that particular specific class. And then we have the methods. Last time we talked about the method. We have different type of not type of method, but we have the methods which can have return one value. They can take some parameters and do some processing on those parameters and return us the answer, or maybe they don't return the answer. So these are the methods we can define. Then we have the properties. Properties are more like a method, but they look like a field. That's a bit strange, but actually they are the methods which help us to identify. We will give the example, then it will be much more clear. Then we have the events and constructors. We can define, like if you have done some GUI programming before, or maybe you have, some people are going ahead and they are trying to understand how we can solve the assessment in which we have the GUI programming. In the GUI programming, we have the button and then say that on-click event. So that on-click event has been defined in that particular button class. That's a class which has been already predefined in a specific library in the C# language. So we are just using that particular specific class, and then we are saying that we want to implement their own click event. If you don't implement, it will do the default thing, it means do nothing. So we can implement those things, we can change, we can have the events. If my class is visible to user and user clicks something or click with the mouse on it, what this class will do. So we can define those events. We can also define the constructors or operators. We call it operator overloading. Plus, whenever we have a string object, we say plus and then another string. Actually, it will do the concatenation. So actually, we change the behavior, change the default plus sign. Plus sign is adding two numbers, not concatenating two strings. So in this string class, we have defined that plus operator, what it will do. So we can define the events in a specific event, what my class is going to behave like, what my class is going to respond with, or we can also have the operators that we can overload or we can define in our class, and then it can do the wonderful things. Using that operator, we can do the things. We don't need to worry about that, just like we do the concatenation using the plus sign. And then we also have the constructors. Constructors are a special type of methods. And one more thing, except these fields, method, properties, events, constructors, they are all methods. They are all methods. Event, they are trying to handle specific type of event. Click. You are typing something on the keyboard, that's an event that's happening in the computer system. So how my class is going to respond to that event. Operator overloading, again it's a method. Constructor is a special type of method which is auto executed when you are creating the object of that class. We have a blueprint of the house, now we have asked the builder to start building. So there are some things that before it can start building the object, it needs to initialize certain specific property, maybe sign a contract or something like that, between two parties. So this is a contract that how we're going to do or build the house. So constructor is a special type of method which is going to be executed whenever we are creating the object of that class, and I will show you that what does it mean. A class can be imagined like a large box which contain the logical different layers, different type of layers. It has fields, it has properties, it has methods, it has events, it has constructors. So different type of logical grouping and things are available. Syntax is very simple. Class, keyword, reserve word for the language. You type a class, and after that we have a name, identifier. It's a variable name. But remember one thing, whenever we are creating the variables, they start with the small letter, and then we have the camel case. If it has multiple words in that variable, then for every second word, the first letter will be capital. But in the case of the classes, we say that that's a normal routine, or what you can say, the best practices, that the class name starts with the capital letter, and after that it's my capital start my, and then class C is capital. So again the camel case, but starting with the capital one. And after that, these curly brackets, this is called the class block, and in the class block, everything that belongs to that class, it will come in between that. And remember that in our program, that program class that is auto generated by the C# system, and it put a main method over there. So everything that is writing in the program class, it remains within that particular specific program block. So similarly, we have the starting curly brackets, ending curly bracket. This is our class block. Whatever we are defining here, that will belong to that particular specific class. Class, we have some fields, we have some variables, and we can make them private, we make them public. Okay, so we have int my variable string name. So we have certain fields that we have defined inside it. Then we have that particular specific methods. Get user input, print the message, it performs some specific things. We are getting the name from the user, we are writing that particular specific my variable, on getting the variable as integer, so we are getting the value, and then here we are just printing them on the screen. Methods, fields. Is it clear? Any questions till now before we can move to the next one? Add a class in the project, we can add, and this is our default program that is here. We have a program, and then it has a main method, and it just print one hello world on the screen. How we can add a new class inside? So we can just go here. We have the solution name. On the top, we have that solution, and then we have the lecture 07, that is the math project. And remember, maybe you have notified that in the one solution, we can have multiple projects itself. You can right click on that particular solution name and then say, I want to add a new project. You can add a new project, you can add multiple classes inside it, you can do the things. But right now, we are trying to do right click on that project name, lecture 07. When we click on that, it will show me, right click, and then we find out that add. Once we click on the add, it will show you want to add a new item. You click on the new item, it will show you that you can add. So again here, we need to select the class here. It's right on the top here, C# class, and then here in the downward you need to provide. It's a myClass.cs. So don't remove the .cs, just whatever that class 1, class 2 that is here there, you can just remove that. Before the .cs, you give the name of the class, and you press add, yeah. Select the class, give the name, and then you press on the add. So it will add a new class. Okay. So for example, I have added that class and write down that particular specific code inside that circle class. circle, and then what information are relevant to circle? Radius. What will the size? That will give us the size. So we save this radius here. Then we have a set radius. That's a method. Because looking at the radius, we say that it's a private one. When it is private, it cannot be accessed outside the class. But do you want to have those information about some specific object that cannot be accessed out of the class? Yes, it is possible. But why we need to have those information if nobody can access it? So you need to give them an interface so that the people which are outside, yes, we don't allow, nobody is allowed to put his or her hand into my pocket and bring my wallet out. But if a police officer come and then said, okay, show me your identity, he is not allowed to do this thing, even if he is a police officer, but he can request. And then we have an interface, okay, yeah, this is my identity and you can. So private, yes, these informations are private within the class, but we need to give an interface so that the people which are not, or the objects or other objects, because here when we talk about the classes, so the other classes can request the information from that particular circle class. Can you tell me what is your radius? So that I know that how I can draw you on the screen. So we have this particular set radius and get radius. Set mean we are changing the value of that radius within the class. So it will receive a double value and change the radius with the new one. Get mean we are getting back whatever the information, whatever the value of that radius inside the class, which is private, which is hidden, we want to get out of it. So it will return back me that particular specific radius information. And then we have the area and circumference. We can calculate the area, we can calculate the circumference. Is it clear that what's happening in this class? There is no main method here. Because as I told you, if you have multiple classes, and now you can see that we can have multiple classes within the same project, but only one class is supposed to have the main method. And if within the same project you have multiple classes with the main method, the compiler will give you an error message. You need to tell me that which class you want to execute, because I can find multiple main methods and I cannot decide which one need to be executed. Either you need to remove from one, or you need to tell the compiler, I want this to be my startup class, and that is a startup class, so this main method will be executed, not the other class. And again, it depends on which specific language you are talking about. Sometimes they ask, okay, tell me which is a startup class, and sometimes say, no, you can't have two main methods in the same project. You have to remove one. Depending on the implementation of that particular specific compiler, it may change. But the point is, only one main method is allowed. So here we have the method, we have the fields, but no main method. Again, we have the rectangle class. In the rectangle, we have length and width. We have private properties, private fields. Okay, and then we have set length, get length, set width, get width. So we are getting those things. And then we have the area and perimeter. It will give me the area of that particular specific rectangle, and then perimeter mean what are the length of the boundary walls. Methods are there. Fields are there, two fields, which are both private. So we have a set and get method, so we can access them and return them. Square, again, in the square we have only one side that is required. So we put that particular specific as a field, and then we have a set field, get field. We can get the area, we can compute the area of a square, we can compute the perimeter of the square. Now we are trying to use those classes, circle, rectangle, and square. In the main program, I remove that particular specific print statement line, and then I say that I want circle. We are declaring the variable. So when we declare the variable, what happened in the RAM? Look, if you look at the RAM, is there any circle here? No. Is there any rectangle here? No. Is there any square here? No. So we have defined those classes within our code as a class file, and we have written down the code, the details, what is the designing, blueprint of that class, but it does not exist in my computer yet. It is there inside our program, but it does not exist in the RAM. When we have started this particular specific program, although I have not shown it here, but this program as an object, or what you can say as a reference, exists in the RAM, because otherwise we can't execute anything. Anything that we want to execute, it should be in my RAM so that we can execute. So this program is actually there, which is that particular specific main method or code, you can say that. Executable lines, these executable lines, 1, 2, 3, 4 executable lines exist inside the RAM. If they exist inside the RAM, then we can execute. But the class, circle class, rectangle class, square class, they does not exist. They are just a code right now. But when we do that circle, so what happened here, it will create not the circle itself. Again, remember, we are just declaring the variable, and as I told you, class is a reference type variable. It will create a 8-byte, reserve an 8-byte to save the address of the object, which we are going to be created in the next line somewhere in the RAM, so that that particular specific address variable or the reference type variable, 8 bytes, depending on, again, it's a 64-bit architecture or a 32-bit architecture. If it's a 32-bit architecture, then it will be a 4-byte variable. Otherwise, it will be an 8-byte variable, a bigger or smaller, 64 and 32. So it's a reference type variable, 8-byte, nowadays is a standard 64-bit. So 8-byte variable, which can hold the address of a memory area inside the RAM. It is not the class object itself yet. So we are declaring the variable, reference type variable. In the next, what we are doing, we are creating the object. So this is the part, new. When you say new and circle, and then put the curly brackets over there. Did we define any method over there? Constructor? No, inside the class. But whenever we are defining a new class, the system itself defined a constructor, which does not do anything. It does not do anything, but it defines a default constructor. So when you say new class, it will execute that default constructor which has been auto-generated by the system. It's not doing anything, but it is auto-generated. It is there. So it will execute that particular specific circle. It will reserve a memory area. Why it is? It is a radius variable, and then we have the methods here. So this is a class object which has been created inside the RAM. Now it is an object. Class is a blueprint, and this variable, this memory area, which now it is inside the RAM, this is the instance. This is the object. Class, blueprint, and object. So they are two different things. So we have created the instance of the class or the object of the class that take up some memory area in the RAM, and we have the address of that particular specific memory area that are we going to assign here inside the reference type variable, that is circle. And now in the next line we are saying that circle.set. Circle, we are saying that we are asking this particular specific variable, that's a reference type variable, go to the circle class or circle class object or circle instance, go to that particular specific object or instance and execute the set radius method with the input value 4.5. So it will change the value of the radius to 4.5. Is it clear? So we have a dot to access something inside the class. The variable name, that is a circle, and then dot and accessing something inside the class, and you can only access the methods or the properties or the fields or the constructors which are public. If they are not public, you can't access like that. For example, if I go back here and make that particular specific set radius private, no, circle.setRadius, it will not allow you to access that particular specific method, because this is the private, you can only access inside the class. Maybe I will show you give you the demonstration, that will be much more clear. Okay. So we make that one, then we change the radius value, and then again in the next line what we are saying, we are saying that area of a circle is, we want to print something on the screen and say circle dot area. Again we are using the reference type variable of the circle type, and then dot area is a method which we are executing, which we are calling, which we are invoking here, and it return me a double value that will be printed on the screen. Clear? Up to that point, how we are going to use our classes here. And similarly, we can use the rectangle class or the square class. The only thing is we need to declare and define the variable. So here again, blueprint, design of that particular specific class, but it is not the actual car. This is a design. On the left side, you can see the design. So it's a design. It is not the actual car. It is on paper or maybe in an electronic file, but not the actual car itself. So class is a design, and the instance or the object is the actual thing which happens to be inside the RAM. Here we have a circle class, and this is our actual object which exists inside our. So this, the class that where we have written down the code, that is a design, that is a blueprint, and the actual object, they are two different things. Is it clear? Again, this is the same instance versus objects. So this is our actual object, this is the design. Constructor. Constructor, a special method that is executed when the object of the class is being created. At the time when we are creating the object, the first thing it will do, it will execute that particular specific method. Normally we can initialize the initial state. Initial state, for example, you are creating the object, you can define the power of that engine, you can define the color of that particular specific thing, what will be the interior type, it will be a cloth, it will be a leather, what will be the color of that interior, and so on. So we can define those things when we are instantiating that particular specific class. After that you can change. You can go and, okay, I want to repaint my car, change the color, yes, that's possibility. But at the creation of that particular specific class in car in the factory, they have some initial things, initial properties that they need to set. What will be the color, what will be the power of that engine, and so on. Later on, if you want to do some modifications, yes, you can do that, but at the creation of that particular specific car, they have certain specific initial set the state of that particular specific car. The same thing we can do with our objects. Maybe we have multiple fields, and those multiple fields, and if you are defining them, they will have the default values. If it is an integer or a numeric type, they will have the value 0, but that you don't want. Maybe you want to change that particular specific default behavior and initialize with some specific value. That you can do in the constructor. So one or more constructors, just like the method overloading, we can have the constructor overloaded. Again, based on the number of parameters or the type of the parameters or the order of the parameters. Same rules apply that we have studied last time, how we can do the method overloading. So we can do the constructor overloading because it is a method. So based on the number of parameters, type of the parameters, or the order of the parameters, we can do the constructor overloading. It means that we can have multiple methods inside it or multiple constructors inside it. Syntax is very simple. The name of the constructor will be exactly the same as the class name. Circle, rectangle, square, and it must be public, because if it is private, it cannot be accessed outside. So it must be public. Public and the class name, and then brackets or parentheses, and then the brackets. So this is a default constructor which has been auto-defined or auto-generated by the system. You can also do something here. You can say, I want to have that particular constructor and I want to do something here. Yes, you can do that. You can change that particular behavior. So this is the default constructor with 0 parameter. And that is what we have actually used here. New circle, and then we are putting the brackets here. So actually we are calling that particular default constructor to construct the object. Okay? So we can have the constructor, for example, I'm saying public circle and this dot radius is equal to 1. Default constructor, and now I am changing that behavior. Instead of having that particular, where is my radius? Here is a radius, double radius. Default value is 0.0. So I want to change it to 1. Yeah, it is possible. So I just go into that particular default. It does not have any input, but instead of having the radius value 0, I say make it 1. Okay, so this is a default constructor. Then we have another constructor which take one radius value or one double value as an input, and whatever that is coming as an input, we are assigning that value to the radius. And don't worry about that this means this dot radius. This means we are talking about this particular specific radius. If you just say radius is equal to radius, it is also perfectly fine, understandable by the system itself. The first radius is actually the field, and the second radius is actually coming as a input. So you can remove that particular this, but that will kill you, okay, because the names are same. So just to differentiate, okay, this dot radius means we are talking about the field within the class, and this radius, that is second part, that is coming as a parameter. Okay, and then again the rest is same. We have area, we have circumferences, we have these things. Remember that we talk about the what you can say that about the variables when we talk about where in the part of the field, where part of the code where they are accessible. What was the name? Its name is skipping out of my mind now. Scope of the variables. Scope of the variables. And now again, if you look at that here, because we have defined this radius in the class, this particular specific radius variable can be accessed anywhere within the class. Anywhere. This particular specific double radius variable, which is a private one, which is a field in the class, we have defined it globally. Globally mean within the class, not within any method. Okay, so within the class, so it can be accessed anywhere in the method, anywhere in the class. So you can see that where here we are when you say radius, we are talking about this radius. In the area, when you say radius, we are talking about this particular specific radius. When you say set radius, and then we say double radius is equal to this dot radius. So again, this dot radius, of course, we are using this keyword. Actually, it is we're talking about this. So we can access that particular specific radius field anywhere within that particular specific method. On the other hand, if we talk about the radius which we have defined in the second constructor, that is a parameter, it is only accessible within that particular specific method. We also have a set radius, and then again it has a parameter as a radius. This particular specific radius variable is only accessible within that particular specific method. So we need to understand the scope of the variables, where they are accessible and where they are not accessible. Okay. So again, the member of the class can be variables. We have seen it. We have seen the methods as well. We have constant names, and we have some properties. So properties. So if we look at that, I have defined this particular specific public double radius. We are saying that public double radius. I just try to remove it because it's on the black, it's not much. So when you talk about the public double radius, with the capital R, and then I start the curly brackets, and we have a set and get methods. So actually this is a method exactly the same that we say that we have defined this with the double private double radius with the small r, and we have a set and get methods. So we have a field, and then we have set and get methods. So actually this particular capital R radius, the public double radius, that is actually the set and get methods. And if you look at that, we are saying that set this dot radius is equal to value, and get return this dot radius. So whenever we say circle dot capital radius, if we say something is equal to circle dot capital radius, it will get the value of this particular radius private variable and return over there. And if we say circle dot capital radius is equal to 3.5, it will take that 3.5 and assign that value to the internal radius property. So actually this is the method which is help us to set and get the value of the private radius field. Is it clear? The property, set and get methods, but writing in a different way. Now we don't need to say that dot set dot get. We don't need to do that. We can simply say circle dot capital R radius. If it is before the assignment operator, it will set the value of the private radius. And if it is after, or we are just using it, it will get the private radius value. So actually the property is set and get methods. That's it. Is it clear? The circle dot set radius, or we can say simply say that circle dot radius is equal to 4.5. So instead of calling the set method, we are just saying that radius is equal to 4.5. Actually it will act like a set method. So we call them properties. Okay. These are, again, if we have defined this particular specific part, we can get rid of these two methods, set radius and the get radius. Because we have defined that specific property, we can remove those set and get methods. So public int my value set and get. Public int my value set and get, it will just define a property my value that will be of integer type, and you can assign the value, you can get that value just using this particular circle or my class dot my value. If it is before the assignment, it will set the value, otherwise it will retrieve the value. Now we are setting the value, my value is equal to 4. So it means the value of that my value int my value will become 4. Static field. In the main method or the method last time when we studied that all the method must be static. Why? Because the main method is static. So if you want to access those methods in the main method, you have to make them static. Okay. So I have defined a circle class here. And if I just try to see that we have the static int, we define that static integer value and say assign is equal to 0. And then every time we are creating the object of that particular specific class, because this is a constructor, so whenever we create the object of that class, it is going to be executed. So in the constructor, we are saying that increase the value of the my number of objects, the static value. Okay. So we are increasing that number whenever we are creating the object. So what happened here? We have a circle. If we look at that particular specific code, we are creating that particular specific circle here, circle 1, circle 2. So it will create that particular circle 1, circle 2. These are the reference type variables. And then we are creating that particular specific object. This is the first circle 1 object of the class. And then this is the memory area, which is a shared. The static things are shared among different objects. Only one copy of the number of objects will be there, and if we are trying to access that particular specific copy anywhere in the method or in the class, actually they are going to access the same one. So when you create the second object, actually it is changing this main one, and whether now we access this number of objects, that is a static field, whether in the circle 1 or whether in the circle 2, the value will be 2. It's not like in the circle 1 we have 1, in the circle 2 again we have 1. No. Static fields and static methods are shared among different objects, but non-static fields are not. Every non-static field will be exist inside the instance of that object. So radius and radius, they are non-static, they are not shared. So here the radius is 2.5 and there the radius is 6.57. Non-static, not shared. But the static field will become in the common memory, where every different object, maybe we have thousands of objects of that circle class. Yes, we can create. Just like we have one design and we can create millions of cars from that design. So design is same, but number of objects are millions. So similarly, class is one, but we can have multiple objects. So we can have thousands of objects, but thousands of objects will share this number of object thing, and that will remain same for everyone. Is it clear? Static fields, shared memories among different objects of the same class. Okay, so not static members can be accessed without creating the object of class. Static members, not status. Okay, static members can be accessed without creating the object of the class. What does that mean? Okay, what's happening? Just a moment. Animation, add that animation over there. And return back. So now you can see static members can be accessed without accessing. So we have the static field here, okay, and then is there any static method here? No. So in the main program, we are saying that now in the first line, number of objects in is circle dot number of objects. Did we created the circle 1 class or object or circle 2 object? No, we have not created it yet. So we are just saying that circle, that is a class name with a capital C, not a variable, circle class name, dot number of objects. So we are trying to print that on the screen. So here we have circle 1, circle 2, we are creating the objects that will create the objects that you have seen here. Okay. Once we have, before we creating the object, we try to print that we want to see that how many objects are there, because we have assigned it the value 0 in the beginning, that's default value, and then at the end creating two objects, we are again accessing that particular static field and trying to print on the screen. So you can see that it is print 0 when it is accessed first time, but after creating the two objects, it is giving the value 2. So static members of a class can be accessed without creating the object. That you can see, it's clearly visible from the first line of the main method, that circle dot number of objects. We have not created any object of the class. We say this is a static field and we initialize with the 0 value, so the 0 will be there. The common memory or the static memory of a class is auto created before even we create the reference type variables or create the object of the class. And we can access them even without. And if you remember that we have the main, we have this math class, and then we are accessing the pi. We have a math class, we are accessing the power. So these are the methods which exist in the math class, and that pi is a static constant, named constant. Remember that we can define this named constant inside our class or inside our method. So static pi, that is math.pi, is a static constant field which has been defined inside the math class. And similarly, this power, POW, or power, is a method which has been defined in the math class. Did we created an object of the math class here? No. We are just saying that math, name of the class, dot pi, dot power, dot sqrt, that will help us to do the square root or something. So all the main method which exist in the math class, we can access them without creating the object. Why? Because they are static. Even we have, there are two constant values which has been defined in the math class, they are also static. So we can access them without creating the object. So static fields or the methods can be accessed without creating class objects shared among all methods of the class. And here math.pi, math.power, we didn't create the math object, but we are accessing those constant and the method. So they are actually static fields or the methods. Okay. Main method is also static. When we execute our program, do we create the object of the program class? This is our main class. This is our main class program. Did we create it? No. But we're still executing the main method because it is static. So without creating the program class object, we are executing, or actually the system is executing the main method. So that is why this main method must be static, because we are not creating, or the system is not creating the object of the program class rather than just executing the main method. So that is the reason that main method is static. And inside the static method, we can always call these static methods. That's why in the last lecture when we talk about the methods, I told you that we need to have all the methods static. The access modifier, they must be static because we are going to access them inside the class. Yes, we can change that particular behavior. We can say that don't make all the methods static or make them non-static. But if you want to do that, then just like we have created the circle class object in the main method, we can create the program class object inside our main method, and then program dot whatever that variable you have created, my program dot method name, you can access the non-static variables or non-static methods, but you have to define the object of the program inside the main, and then you can access the methods which are not static. Is it clear? Anything before we can move to the structure about the classes, because this is what we are going to study. Of course, there are certain relationship between the classes. That's something which is beyond the scope of this course. These are called advanced programming. When we talk about the object-oriented programming, we will talk about more. But right now, object is different thing. Class definition is different thing. Object is a memory area which exists inside the RAM, and class is actually a definition of that object, how it is going to be created, how it will look like, what are the behaviors, what are the fields and properties, and so on. And we talk about the static members can be accessed without creating the object of the class. Up to the class, if you have any questions, let me know. Did you understand that we can access that particular program, the non-static members of the program method inside the main method, just create the object of the program?
Do we need to know all the classes for the first
Yeah, this week is also included in the class. So the concepts are there. Concepts mean that, do you think that class and class definition and the object of the class are different? Yes or no? So yes, answer is yes. So the information, the concept, yes, you need to know. You can create some classes, just like circle, math, because right now I have not defined any lab for this week. The reason is that that is something which you can define, you just like the circle, and then try to use it. Maybe I will just write a few tasks for you to do that in the lab, but that is something which is the main thing that we have studied. What are the variables, how they are being assigned, value type variable, reference type variables, methods, arrays. When we are passing the parameters from one method to the other, they are passed by value, they pass by reference, what will happening, how the program is executed, what are the flow of the program. So these are the important things. Right now we can have multiple classes just to ease our structure of the method, rather than everything in the one program. Having everything, we can have multiple classes, and then we can try to, because classes help us to logically separate one part of the code from the other, because if anything related to one part, that should go into that particular specific class. Okay, so that is one thing. Any other question? Okay, so structure is also a kind of, I mean, it is almost same syntax as classes, but they are not reference type variables. They are lightweight objects, you can say that. Contains constructors. They have constants, they have fields, they have methods, they have properties defined using the struct keyword, and they are value type. So there, when you create the variable of the class, actually it creates a reference type variable which can hold the address of the actual object. But this one is no. Directly a structure or the object of that structure is being created and assigned the value directly to the variable. So that's a value type variable. It's not a reference type. It can has constructors, it can has methods, fields, properties, and if you look at that, it's look like a class, but actually the change is more like, instead of having a reference type variable, it creates a value type variable, and it is more like a lightweight object. So within a struct declaration, fields cannot be initialized. So when we are defining the declaring within a struct, fields cannot be initialized unless they are declared as constant or static. Fields, if you remember that particular specific field, where is my circle class here? In the circle class, I am saying that this is static, okay, that's fine. But in the, I can assign the value. Where is my field? Yeah, this one is private double radius. I can say that double radius is equal to 1, rather than having it in the main default constructor. I can assign the value, but that I cannot do inside our structure. Initialized fields cannot be initialized unless they are declared constant or static. If they are static, we can assign some value to them. If they are constant, then definitely whenever we are declaring a constant, we need to assign the value. So there we can assign the value. But if we just say int I or int number inside the structure, that's a field, we cannot say number is equal to something. We cannot initialize that particular specifically. A structure cannot declare a default constructor. A structure, it cannot have a default constructor. A finalizer, again, this structure cannot be defined. In the class, we have a constructor, we have also a destructor. Destructor, just like in the constructor, we are initializing certain things. In the destructor, we can do something before that object going to be disappeared from the memory, what we want to do. Maybe there are certain specific information that we want to save permanently in the field, in the file, or maybe in the database or something. So you can write that specific code before that particular specific object is deleted from the memory. The information that you want to save inside permanently, maybe in the file or maybe in the database, you can do that in the destructor. So before that object deleted, you can do something. That is a destructor. Just like before that object is created, you want to initialize or you want to do something, then you have a constructor. And before the object is deleted, you can do something that is in the destructor. So in the class, we can have constructors, we can also have destructors. But in the structure, we cannot have a destructor. Structs are copied on assignment. When we are assigning one variable to the other, circle 1, circle 2, two objects have been created. When we say circle 1 is equal to circle 2, what will happen? Actually, it will assign the reference of the circle 2 object to the circle 1. And now, no longer we can access the circle 1 object because the reference has been removed. Understand? So reference are assigned when we are assigning the one object to the other in terms of the classes. But when inside of the structure, actually it creates a new copy of that structure and assigned it to the variable. Structs are value type and classes are the reference type. So these are again difference between the classes and the structures. So structure is a value type and class is a reference type. Again, can be instantiated without using the new operator. In the class, whenever we are creating the object, we always have new class name and then parentheses. We are maybe calling the default constructor or maybe the other constructor that we have defined in the class. So we have a new keyword whenever we are creating the object of the class. But here, no, we don't need new without using a new operator. No inheritance, the relationship between different objects, different classes. So that is something, as I told you, it's an advanced thing that does not exist inside the structure. In case of structure, can implement interfaces. We're not going to do that one. A structure can be used as a null type, nullable type, and can be assigned a null value. Again, structure can be null. They can assign a null reference. They are pointing to nothing. The members cannot be specified as abstract, virtual, or the protected. So we can't use these kind of the what you can say that the access modifiers with the fields within that or the members within that structure. So these are certain limitations what we can do with the structure and what we cannot do with the structure. Faster than the class because they are value type, they are lightweight objects. Class is a heavy object. Okay, you want to have the functionality of the class, but you don't want to make your program more, what you can say that resource hungry or the slow. So then you can use the structure. Use structure whenever you want to store data, only good for game programming. Yeah? Like we want to save the data, there's no relationship between different parts of things. Yeah, we can make them. Suitable for lightweight objects, point, rectangle, square, color, which have certain specific information on their own. They are not related to anyone else, so we can do that. Length and width, again, rectangle, we can do that. This is instead of having the class keyword, I put the structure. The public struct rectangle, and then we define the things. Exactly the same. Again, my rectangle, length and width, this is a constructor. We cannot have a default constructor here, but we can have a constructor here. And then we say int new area, length and width. So we are defining the things. Area of rectangle is 144. So when we define those things like here, 12 and 12, so we are assigning. So now we are not having that constructor say my rectangle, without having. We just declaring the variable. So because it is a value type, it will create the complete structure of that thing. It is not creating only a reference type variable of 8 bytes. No, it is going to create the whole structure itself, the object or the instance of that structure, without using the new keyword. And then we are saying that my rectangle dot length is equal to 12. Why? Because these are the public variables. Because they are public, so we can just directly assign those values to them. Dot length, dot width, public things we can access outside of the class. We access them, assign the value, and then we are just calculating the area. Again, the same thing that how we are using with the class name, class variable name dot something that we can access inside the class, inside the class or the, here we are trying to access that area rectangle method and print that thing on the screen. Okay? Area of a rectangle, show me the things, error compilation. Okay, so compile error, so we say are defining the rectangle, and then when we are trying to do area rectangle, remember we have not assigned the values of the length and the width, and because we have not assigned any values, so we are trying to access it, so it will give me the error message here. They initialize the members variables with default value 0 for the int, and so when you say this part, it will only create, and this does not initialize the values of the members inside it. But when you say new, it initializes them with the 0, and now we can access them without any even is initializing. So definitely when it is 0, it will give me the value of the area 0. Or we can assign them using the new rectangle, and then we have defined a constructor over there. We are providing the values, and it will assign those values or initialize those values over there. So again, these are different way how we can use that. Okay. Again, structure, we have 2 points. We can find out the square distance between 2 points. So we are defining a structure here, public int x, set and get. So now we are defining them as a properties. Now y is also a property that we have defined over there, and then we say my point is equal to this. So actually we have a my point, and that my point is a constructor which initialize the values a and b for the x and y. The first value go into the x, and second value will go into the y, and then here we are defining that particular specific point. We are defining it a point over there, and then we are saying that point my point 1 dot x is equal to 34. We have y. So either you write this thing, set and get methods, you can do that as well, or you can just simply say get and set. Normally we do this part, that is what you can say that's a comments right now. So if we have something like this, we want to change the default behavior. Default behavior is exactly the same. Get and set, it will, whenever you say dot x is equal to 35, it assign the value to the x, and you say my point 1 dot x and try to print on the screen, it will get the value from out of it. So if you want to change that particular specific default behavior, then of course you need to write down, you do something, maybe you are adding some values into that one before you can assign those things, or maybe it is coming into a different parameter and then you convert that back into that one. So if you want to change that default behavior, then you need to write those methods by yourself. Otherwise you can simply say set and get, it will get and set the value of that particular specific property. Now we are defining two different, we are trying to find out the distance between 2 points. So this is a method that we are defining in the point. So say my point, again it is receiving a point, 1 point as an input, and then from the current point that is also has the x and y value, okay, this dot x then this dot y, and trying to find out the distance between this point. So point dot x minus x1 minus x2, x2 y1 minus y2, take a square, add those values, take a square root. Where is my this one, x2 minus x1 square plus y2 minus y1 square, and take a square. That will give me a distance. So I'm just implementing that particular specific things here. Math.sqrt, again math is a class and square root is a method over there which is static. We can just access that particular static method without creating the object of the class. So this is how we are going to, we have a point 1, we have a point 2, and then we are printing the point 1 and 2 on the screen, and then we are computing the distance between those points and printing them on the screen. Is it clear? multi-dimensional array. Okay, so let's have a break and then we can talk about, I don't think I put that, that what you can say, that stop point.